So we have acceleration is a rate of change of velocity. And this formula should look kind of, sort of familiar there. It's related to our slope formula. Come on, pen. There we go. So acceleration is when your speed changes. So if you're in a car and you step on the accelerator, the gas pedal hard, you're gonna, jerk back because your speed increased. If you step on the brakes hard, then you're gonna jerk forward because your velocity, your speed just changed again. So acceleration just measures your change in speed, like when you're driving a car. And it's just a slope. You take the change in one variable divided by the change in the other variable, and so acceleration is basically the slope for speed. And then they talk about what each of those letters means. So we have v is some final velocity, that's like the second y value, and v0 is the initial one, so that's like the first y value we're given here. So these are just like y2 minus y1 in the top. In the bottom, our independent variable is always time, and so we just have the difference between the two times, end time minus start time. So the first one right here, this column, are the end time and velocity, and in this column over here, those are the start time and start velocity. And so that's what this formula is here. And then they give us some information about how they're choosing to measure for this formula. So both velocities here are measured in feet per second. And then the times are going to be measured in seconds. So if I take my numerator are numbers in feet per second, so to get acceleration, I'm making a fraction. The numbers in the top are feet per second. The numbers in the bottom are just seconds. If we take feet per second divided by second, remember the rules for fractions? What you do is you take the top fraction, and then you multiply and you flip the bottom fraction. So if that was like 2, it would be 1 over 2. So that would just be 1 over seconds. And there's a couple ways to think about that. You could just read it as feet per second per second. So if I just read this version right here, that just says feet per second, right? That's that one right there. Per second is that division right there. So that's one way to read it. If we look at this version over here, if we multiply seconds by seconds, we get seconds squared. So another way to read that is feet per, and in the bottom, we're going to get seconds squared. And I always thought square seconds are kind of weird. I get what a square foot is. I don't quite get what a square second is. So my preference is to say feet per second, but a lot of people call it feet per second squared instead. So this is the more common way to read it. And so we should look at the answers here because one of them will fit either of these two cases when we clean up the units. So what do we got? I have feet per second, no, that's speed, not acceleration. Seconds, no, miles, feet. Oh, here's my last one. Feet per second squared is what acceleration is going to be measured in. If we start with feet per second and seconds for speed and time. And then they want us to try and solve the formula to get the V all by itself. And it's multiple choice, which isn't too bad. So you could just guess, or you could help me walk through this. So I'm going to try to actually solve. So my formula has A equals V minus V0 divided by T minus T0. And I need to get this V all by itself somehow. In previous problems, when we had a denominator, what did we do to get rid of that division for the denominator?
Multiply.
Yeah, we multiply. So the thing is, we just have a complicated thing to multiply by. So what I'm going to multiply by is this whole thing. So I'm going to multiply this side by t minus t0, and I'm going to multiply this side by that same t minus t0. And I'm just going to leave it like that. Like in that other formula, we had sigma times z, and all we had to do was leave it as sigma times z. I'm just going to leave it like that. The point here is I have a number divided by itself. That's gone. Number divided by itself is 1. 1 times anything is that thing. So this is all that's left on the right side. So I've got v minus v0 equals a times t minus t0 in parentheses. And I got to have those parentheses there. I'm trying to get this v right here alone. Right, so this one needs to stay. The other one needs to go. So to move it over, I'm just going to add it. So I'm going to add that v0. And so if I take a number and add it to its opposite, that just goes away. That's just a 0. But on this side, I got to do the same thing. I have to add that v0 over there. So that's gone. All that's left is v on the right side. So the answer's got to be this stuff right here. T minus t0 times a plus v0. And so now we just need to look in the answers they give us for the thing that looks most like that. And yours will be in a different order than mine. So let's see. The first one, no, that doesn't look right. I added that v0 over. So that one's not that one. This one has a fraction, and mine definitely had no more fraction. All right, so that's not it. It's not that one either. This one has the a times t minus t0 and a plus v0. Let's see. They just wrote these in a different order. Does it matter what order you multiply in? The answer is no. So, okay. So they're saying it could also be written as a times t minus t0. They just switched the order of the multiplication plus v0. Yeah, that's okay. I'll take it. That makes sense? Or not make sense? That's got to be the right answer right there, I think. And yours may be in a different order. So I'm trying to find the one that looks closest to mine. Okay, moving on. Let's see, we have 2 more. Car was stopped at a red light. When the light turns green, the car reaches a speed of 27 miles per hour in 3 seconds. Okay, so let's try it. And we just have to make sure all the units match. So what are we given here? A car was stopped at a red light. So stopped, if you're stopped, you're not moving, you got no speed. So one of my v's is equal to 0. So either v is 0 or v0 is 0. And I guess it's got to be v0 because that's how it starts, right? This should be my starting speed. Starting speed stopped is 0, okay? Light turns green, and then the car reaches 27 miles per hour. So that must be the next V, 27 miles per hour. And then they give me 3 seconds. So that must be the T that goes with that. And I got a problem. This says seconds, that says hours. I can't mix seconds and hours. I gotta just pick one. So we gotta clean that up. Let's see, when we started the problem, we're supposed to have everything in seconds. So that means here we need to convert in order to continue. We can't use the formula yet. We have to convert 27 miles per hour into some amount of feet per second. So I'll show you the standard way and then the other way. So things I need to know here, there are 5,280 feet in 1 mile, and you may remember that from a previous time in your life. And then For seconds, there's 60 minutes in an hour and 60 seconds in a minute. 60 times 60 is 3,600. There's 3,600 seconds in 1 hour. So I just had to think about, or maybe look up, what's the relationship between miles and feet? What's the relationship between hours and seconds? And we could put minutes in between, but this allows me to skip it. So if I want to convert 27 miles per 1 hour, here we go. To get rid of miles, I'm going to put a miles in the bottom and change to feet in the top. And I know from above here, there are 5,280 feet in 1 mile. So to get rid of miles, this says multiply by 5,280. Who cares about dividing by 1? It's kind of boring. And then if I want to get rid of the hours, since hours is in the bottom, I'll have to put an hours in the top to cancel that. And that puts seconds in the bottom. And up here, I know that there's 3,600 seconds in 1 hour. Since this is in the bottom, that means I'm dividing. So this all tells me to convert, take the 27, multiply by 5,280, and then divide by 3,600. So I'm going to try that in my calculator, and then I'll show you the other way. Calculator, 27 times 5,280 divided by 3,600, 39.6. That would be feet per second, because I got rid of hours too, and the only thing left are feet and seconds. Other way to do it, Google it. So miles per hour to seconds. Somebody will have made a little app to do that, like Google. Thank you, Google, you're so sweet. And so I had 27 miles per hour, and Google says, yeah, that's 39.6. Did it right. So that's the number I get to use in my formula. So then I plug into my formula and see what happens. So I'm trying to find the acceleration, and my formula says A equals V minus V0 over T minus T0, and we plug in. So the V, instead of 27, is now 39.6. And that's the ending speed. The starting speed, they told me, was 0. Oops. Minus 0. In the bottom, they said that this speed happened after 3 seconds, which means if that's 3 seconds later, the starting time must be 0 also. So then the acceleration is going to be whatever 39.6 is divided by 3, which, guessing without my calculator, I think is 13.2. And I took feet per second and divided by seconds, which is often called feet per second squared. If I calculated that right. So the catch with these questions is, in the beginning, you got to pay attention to what the units were to start with. And then based on those, predict what the other variables' units are. When you make a calculation, you got to be sure that the type of units match. So we can't mix seconds with hours. So I look down to the next problem. What do we got? The final speed, feet per second squared. That's okay. Feet and seconds are what we're working with. We have seconds again. Ah, they threw hours at me again. So here we would have to do a conversion from miles per hour to feet per second to make the calculation. But then after, we're going to have to convert back to miles per hour. So this last one's going to require 2 conversions. And I'm going to stop here and let you guys try that. If you get stuck, there's that message button.